It is midnight. Perfect. Everybody sleeps. Time to make another video. So in this video, I will show you how we can create very nice smooth surfaces with the spline tool. And we will use this water bottle as an example. We will also take a look into how to create more details via the circular pattern tool. We will start actually by bringing in a scan model. The download link for the scan model is actually in the description. Here is the bottle inside Blender. I just brought this in here, cleaned it up, and rotated and positioned it. And then on the desktop, when you unpack the saved archive, you will also have this STL model. This one we will bring into Fusion, so we have a reference to sketch over. Okay, so very good. Let's start with a new file. The first step will be to bring in the scan model. And normally you would go to File, Import, and we don't have actually an import function here. So to import an external CAD model, we actually have to go to the Insert command. Actually makes sense because we have Insert for Canvas, Insert two-dimensional drawings, so why not the mesh model? Click it. Very good. Then you navigate to where you have the file and click Open. The next step is very important. This model was adjusted in Blender, which is my go-to polygon modeler. And Blender internally works in meters. So the unit type when we bring this in should be meter. So then the scale is 1:1 and correct. Okay, very good. So there it is. Our document is also set to millimeters. If we now rotate around, we can see here there are some dents. There are some bumps actually on the surface. That is actually cornstarch. I used cornstarch to make this transparent body more opaque, and then used meter shape to do the photogrammetry to create this model. I rotated it and positioned it so from the front view we have a nice left and right view. Okay, so how do we start? First, we would like to make this bottle less transparent. So right click onto the mesh body, opacity control 10%. That is good. Now we can see actually through it. As always, we want to start working on the easy parts. While this curve is actually more complex, but here we have few linear elements, the center, the bottom, the neck. So let's do that. Sketch on this plane, line command. I start somewhere here, go over, and then I go here to the ground point, click and go this way. I on purpose make these lines crooked just to show you how the constraint system works to straighten everything up. Horizontal constraint for this, vertical constraint for this. Here we have a perpendicular constraint. I will delete this and replace this with a horizontal constraint. Dimension wise, now this curve will come down, and then here at the bottom it's rounded. So this line has to be a little bit longer, maybe like this. Yeah. Let's add a dimension by pressing the D key or going to sketch dimension. 30 is good. This length here, I know it's 225. And then now we can select this point and drag it around and see, okay, so where would this look good? Maybe here. This feels good based on the scan. Maybe a little bit of tidy up. 12.5. What's the length here? 25. Very good. Okay, good. So now we have actually this part done. Now we can take a look at how do we do the curve. There are actually three ways. We could work with many arcs and try to model this till this actually fits. Please don't do this. I'm just more making a kind of like a small quick demo. And then you can see, however, now with 2 arcs, it doesn't really work. I might need more arcs, and I'm really limited to the shape of arcs. So, welcome to Splines. We have 2 types, fit point and control point. Let me go over the difference again. Fit point, the curve runs through the points, and with a control point, it starts at the first and ends at the last point, and then is inside. By moving this together, I can pinch the curve, and here I have handles which I can use to change the flow. And they all are pretty much 90% the same with tiny differences in their application. So here, it doesn't matter which one we use. I will show you actually how to use each one. It's quite interesting. Now, when we take a look at the curve, so one of the main rules is this is nice and fluid. This is a little bit linear, bend, a little bit linear. We want to use the least amount of points. Little demo again. You see how nice and smooth actually this is. I can probably create the same with more points. And after quite some time trying to clean this up. Now for our eye, this actually, maybe they look equal. But check this out, right click Curvature Control. Right click Curvature Control. And I will move the whole curve actually to the right. So you see when I select this point and move it around or select the handle, you see this red line is nice and smooth. You see now here, it changes the flow a lot. So when I want to get exactly the same shape like on the right side, you see how much work that is, trying to position all these points. That's a good example to show you why it's not good to have many points. It's simply more work to create a perfect flow. When I say perfect flow, for example, here with this now, we can see that here the surface or the curve changes the direction and gets a little bit flat. But here it's a nice continuous bend. I always find it very easy to imagine these fit point curves as a piece of plastic, a stick, and we bend it over points. And the plastic always wants to straighten itself. So, fit point curve. We will start at the beginning. Now we need to figure out how many points do we need. I will go first actually with 2. And then at the end, click OK. So let's hide actually the water bottle. Down here, this is good how it starts, but up here, I want the curve to flow smoothly into the line. So we have here actually, it's called curvature. Some programs call this smooth. They also call this there create a smooth continuous curvature, or some just simply call it a G2 transition. What G1, G2 means, I will explain just in a moment. So this is better than tangent, but a little bit more complicated to use. Curvature, click, click, and there we are. You see now this basically pulled this handle, so this is aligned and the curve flows perfectly to there. Okay, so escape, so we are not adding any more constraint. And now we can see, well, when we move these points around, what can we do here? Yeah, maybe there. See, it's a push and pull a lot, a little bit. this handle maybe a little bit further down. Okay, when you press the M key, it's actually a lot easier to move these points than by click and drag. Okay, good. So now with this done, let's right click and take a look at the curvature. Okay, good. I will copy and paste and move this curve to the right side, simply so I have a copy. And then here I will turn on the curvature control. Okay, good. Actually, I will cancel this for the moment. And this one, I will turn this curvature control maybe off for the moment. So it's easier to see the curve. And now I will delete this point. This goes back to least amount of points as possible, just less work. Let's turn this back on. Try to see, okay, so where do we have to put this point? Maybe here. Okay. And this one here, maybe a little bit up. I just pressed escape and then that stopped actually the transformation of that point. Yeah, that doesn't look too bad. So let's take a look at this curvature now. You see how this is a really nice flow. In here where we have multiple points, this changes the flow a lot too much. You see this is very even, and here this is not even. No, because just one point. Goodie. So let's actually turn this off for the moment, and let's see how close are we. Up here we're a little bit shorter inwards, that's fine. Here maybe we move this on it a little bit, but then we're not really hitting it there. And here we are off. So we could insert a point, but then we end up back at the problem of too many points. What else can we do? When we click this point, we have a handle here. Let's see with the handle, I can change the flow. When I make the handle short, I get a small rounded corner. You see there's also a green ring, and if I make this bigger, I kind of straighten that line a little bit more. And maybe like this. And you see this is actually more parallel. This looks all pretty good. Yeah, here it flows through that curve anyway, through that point. There. Yeah, that's actually pretty nice. So let's take a look at the curvature one more time. So there we are. Okay, goodie. I'm going to show you now how we can build this via the CV curve so you can see the opposite. So here I just make two lines, okay, and then I say equal, 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 okay, and I also down here need to make this equal to here. Very good. And then this dimension I push over. Create control point. So this is now actually something I know, and I will explain this just in a moment why we do this. One click, two clicks. This is for the transition for G2. Then I know 1, 2, 3, and enter. Okay. Curvature, U to U. Okay. You notice the moment we add this curvature control or constraint, these two lines will become black. And if I undo this and just do the tangent, only this one line. So what this means is actually that this G2 command, G1, G2, works with these 2 points. So these 2 points are perfectly aligned to this line. You see, they are actually at a line. I will go more into this just in a moment. Okay, so now we can actually turn on the bottle, and then let's work on how do we push and pull everything here. There we are. Maybe here, maybe a little bit there, and there. So you see here we work without handles, but we simply position the points till we get kind of like the flow we want. Okay, very good. And what is really important here with the CV curve to know is when we place the CV points, the moment points are closer together, they start pinching, and the more curves or points are away, they're stretching a curve. And ideally, we want also to have them like in even distances, which in this case is a little bit more tricky, but the curvature graph here is fine. What this means is the curve starts bending, and then here's an inflection point because the curve changes direction, which is why the graph goes that way. Okay, now this looks actually pretty nice. So before we continue, let's actually take a look at the difference between curvature and tangent. And again, tangent is G1 and curvature is G2. By the way, coincident is G0. Maybe let's start with coincident. Click, 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 there. So this is what's called G0 or coincident. There's no flow. Basically, two elements meet at one point very sharply. And the same can also be done with an arc. There and there. You see? Just a sharp point. Okay, so that is G0. Now, G1 tangent. Let's take a look at this. I draw a line and I make an arc and I draw a line. Beautiful. The arc flows tangent into the line flows tangent into the arc. Okay. Now let's take a look how the surface visually looks when we add lights to it. So let's go to shaded, and there you can see there the face is highlighted, and then very instantly the arc gets this highlight, and you can see there is kind of like an edge right there. And that is basically what G1 is. It's a more geometrically perfect transition because it's line and arc, but it visually is just not very appealing. Okay, let's go back to the sketch. I will create a line like this, and then I will lock this line on purpose so it doesn't move and it's not horizontal. Perfect. So now I go with the fit point, the CV curve. Again, this is G0, and let's create a transition. Wrong command. There. Now we can see that even better how the highlight, doesn't even flow because it is a sharp edge. Okay. Now when we go back to here and say these two, make tangent. So G1, and pay attention to what happens to this point. You see now that this point got adjusted so it flows to this line. There, this looks better, but here we can still see this very quick transition from the big highlight of the surface to the highlight on that arced surface. So we kind of like have the same here, while this is not an arc, but how this arc flows to here, how this curve flows to here is the same, G1. And essentially what happened is we have this line, and then at this point, instantly this curve starts to bend. Now we will delete this and we go to curvature. Pay attention to what happens to this point, G2. So G0, G1, G2. You see now this line is parallel also to here. And if we compare actually how this tangent result looks like, you see from here instantly it bends. Now we can see that the curve actually continues the direction of the line a little bit and then starts to bend. Whoa, where's that edge? We don't see it. And that is what G2 is about. And then you also have G3 and G4 and G5. That's more stuff for car designers, but for us, G2 is actually very sufficient. Very good. So here this is a line, and thus these two segments are in a line, or these points are at a line like this. Let's go back one more time, and I will make something like this, number one. And then, whoops, 1, 2, and 3. Very good. And I will lock these points so they don't move. And I will go G1. You see where this point is, undo. And then G2. You see that this point is actually not in a line anymore. And that is okay. When we move this, you see how the second point moves, or here. So what's happening is this curve has a direction. And with G2 or G1, these points are positioned so that the curve that comes out of it somewhat continues that flow. So when we add actually also here this, yeah, good luck finding the transition. We don't, because it's perfectly blended. Okay, and that honestly in a nutshell is the difference between G1 and G2. Again, G1 is also faster. G2, while better, is also slower to calculate. So let me delete all this. This is all good. There we are. Perfect. Now we can actually go ahead and create our first body. So let's go to revolve. We'll use this one along here. Very good. Also there, when we take a look now, the transition and the highlights are really beautiful. When we zoom in, even here, we can't see, there's the edge, but we can't see any transition. And that's because this is set to G2. Okay. So with the scan model, when we zoom in, we can see there are few more elements. So we built the main body. Okay, now we can start adding details. So I will go top down into the sketch. Here's the line command, click, click, click. I do this actually very in a very simplistic way, and then we will push everything into the format. Go to control spline point. No, control point spline. And click, click, and then drag this one out. So these are angled because these lines we can also make horizontal and vertical. It's actually pretty cool. And then this line I can drag and drag, and drag a little bit higher. So D, what's this dimension? Maybe 1.5. Here, let's say 2. Yeah. This one we make 1. 3.5 is fine. Now here we could specify an angle, or actually distance from here to here. That would specify the angle of the line. I will go, so this line to this point. You have to be careful what you click. And I would like this to be 3.5. millimeters. Very good. From here to there, 1.5. And what distance do we have here? 5.5, 6. Let's say 6. Okay, very good. Now, you see we added actually these extra elements to the sketch, but then this is not showing up. Okay, so that's a cool part about how we can edit features. Then we click and click, or maybe not always. No, we on the PC it's Control, on the Mac the Command key. Add more selections or profiles to it. You see I'm deselecting and adding this back. Click OK. Cool. At one point we have to hollow this out, but this bottle has actually these interesting elements down there. So let's take a look at that first. For this, we will go to the model and make it 100% opaque again. And then from the bottom, we need to see where is maybe a good area where we could use this as a reference. This is actually back here. So kind of like there. So we go to a right view, then inspect section analysis, this plane. Very good. So there we can see half of the model right at that position. And let's make a new sketch along this view. Fit point is actually in this case fine. Here, click maybe there. The way how this lower area was scanned is not 100% accurate. So this is fine. So we just need to get something that's close, kind of like this. Okay, very good. So we specified, and we can turn the section view off. We specified this path. Okay. Now I need to create the tool that cuts that groove. And for that, I need to have a sketch that I can position onto this line. And like a roller coaster, I want then to run it across here. So we go to construction and let's take a look. There is actually a command plane along path. That's exactly what I want. So click, then I bring it down maybe to here, click OK. And what's really nice is I could go now to inspect, section analysis, click this plane, click OK. And then you can see at this angle, we can look into there. Pretty nice. Back to create a sketch on this plane, because now you can see the sketch we will create is actually kind of having this angle into the body, but it is perpendicular to this center rail. And we can use the control point. So I will maybe zoom in a little bit and then click, click, fill this with a line. Okay, and here's now a little trick. I will ideally on the grid, or actually here, I will draw a line down, make this horizontal, and then this point I want to be aligned with there. So you see now this is centered. This is very important because now, escape, I can select symmetry and say this point to this point, symmetrical to this line, and you symmetrical to there. Very good. Now I can freely just model on one point and you see the other one follows it. Pretty easy. Again, the scan is not perfect, so we just eyeball it. All these exercises we do right now are not made to build something for NASA, but more to understand how this process of modeling works. So this actually feels pretty good. Then we can turn off this section view. We can turn off this mesh, show our body, And now we will go to create and sweep. Sweep does actually select one profile, the one we created, and sweeps it along a path. You along this path. There we are. Sweet. Okay. Yeah. So the nice thing is, again, because this is all timeline based, when we move this point up, undo, you see how everything updates. Beautiful. Very nice. So the next step we're going to do will actually be very interesting for you to see the power of the timeline and how we are going to move features forward and backwards. So now I would like to visualize how does this cut work when we make a pattern. Oh, I do not really like this line here. So why do we have this line? That's because there's a sketch. So we'll do the following: right click, edit feature, and then I just move this to the end. And then from there it starts cutting. Yeah, 10 times better. Cleaner surface, always desirable. To make the pattern circular array, phase along this axis, and okay. Okay, why did this work? I assume this is not going to work. Interesting. Oh, I got fusioned. Interesting that it did that. I did not know that this actually works. Okay. Good. So with face, you can make a pattern of a face. With body, obviously you make a pattern of a body. And with feature, that's actually the one I wanted to show you. We now click on this command. That's the feature. And then quantity 5 and okay. There we are. Now I would like to round this edge. So you, and you. This looks actually really good. I can round those maybe 5 millimeters. And then I can go ahead and round all those. And maybe 1, let's see, 2. Because this is a constant radius, you see here how this gets smaller. If we go with chord, this will look visually better. Okay, nice. Good. Talking about the timeline and how we can move features around. So you saw how actually I did this pattern and then I started adding these features to it. And maybe I don't want to have to select 5 edges. I just want to have select 1 edge. So that means this rounding I need to do before I do the pattern and actually before I even do this this cut. And to be more clean, maybe I should do this even before I start modeling on this part. So now there, I will actually give this a rounding at the bottom. You see how I moved the time marker to the position where I wanted that to do, and everything else should work perfectly. You see, there, now I have this edge already. Because now I can go ahead and say chord length, yeah, that is good. Round, very nice. Feature pattern, okay. Double click, right click, edit. And then for the features, I also, with Control or Apple key, add this one to it. Zack, there we are. Pretty cool, no? So you see how useful the timeline is to restructure our approach to the design. And also at the beginning, we made the bottle and then we went back into adjusting the sketch to add all these elements. And then we edited the revolve feature. Pretty cool. Now at this point, we can actually look into doing a shell command. 1 millimeter. This is probably not going to work well, and you will see just in a moment why. So let's do a section analysis from this view. Okay. Well, what's class talking about? This is all pretty good. Let's go up. Oh, what's here? We have cavities. Yeah, that's not good. So how could we fix this? We could make this shell command simply thicker, 2 millimeters. And we get an error warning? Yeah, there was an error warning. Okay, maybe 1.5. Let's see. Shell, by the way, big warning, is a very tricky command because it is a very complicated task to offset the exterior surfaces into a shelled inside surface. So here we have some problems, so we can't even do this. And I want to maintain having actually here this being filled. So what can I do here? Okay, so this area gets shelled. To prevent it being shelled, I simply have to go back to here, edit feature. I will actually turn the section off, show my sketch. Here, hold then the Apple command or control key, and to be clean, I deselect these two elements. Okay. Do the shelling. There we are. You see? Pretty cool. And now after we did the shelling, now I'm going to add these two bodies back into our design. I'm using this Z-axis here. Suck, join. Cool. Okay, so you see how we brought these pieces back to the end. This is really why I like the timeline actually a lot, because it is a very easy tool to visualize how we build everything, and then we move features or steps forward and backwards. Because when you explore design, you have an idea, but definitely there will be times where you have to adjust your idea. We have a lot of section views, too many. Let's maybe remove some. And this is all good. We could give those names to make this cleaner. Actually, yeah, so let's go to a front view. The last thing now we would like to model is actually the cap. So I will turn the sketch off. I will make a new sketch on this plane. Very nice. And then I will, yeah, how do I find this point? Let me show you another really interesting trick. So we could project this line in. So from the model to there I now have actually this line. And then from this line, I can continue modeling the cap that goes over it. Super easy. Okay. Zip. Let's delete this. I could also, when I actually go into this first sketch, see, oh, this is 225 millimeters. Okay, good. So that means in this sketch, I will just, I make this big on purpose so you see where it is. Draw something here on this Y line, and then I need to make sure these two are vertically constrained. So they go up and down, but not left and right. And now U to U. So with Shift, select these 2 points, dimension 125. 225. Wah, wah. Yeah, you see? Okay, but what happens now if we go to sketch 1 and adjust it? That's not necessarily good. Then we have to go back to sketch 4 and figure this out. And let's go to here, and I move my mouse over here, and you see it says D2. This is dimension 2. This is dimension 4, dimension 3, dimension 1. Okay, so all these dimensions we add have an ID number. Let's take a look at change parameters. Welcome to spreadsheets. Look, linear dimension. And there's actually 225. So we could call this bottle height. Okay, good. And if I go now to sketch 4, go to this dimension 38, double click, and then here I type in bottle height. And you see now actually the red text turns into black because Fusion found that, hey, there's actually an ID with that name. If I press enter, now it says function 225. Pretty cool, huh? So let's go to change parameter and we say, make this one maybe 240. And you see, this is 240. It got adjusted. I just undo and go forward. So we were actually linking this. So this is another way how we can link actually dimensions. This is only as an introduction so you understand and get an idea of possibilities, what parametric modeling means. So I also know that in sketch 1, for example, this is 12. So this is D3, now you see D3. Let's go back to here. There's a dimension, and then there we say D3. Okay, but now it's exactly added. That's plain, but we would like to have a small tolerance for the threading. So we could say, so the value of dimension 3 plus, we are in millimeters in this document, plus 2. Enter. Isn't that cool? Yeah, I think so. Okay, and this one here, 2 millimeters and 2 millimeters. This is actually way too deep. So yeah, maybe there. So what's the dimension? 20. Very nice. Escape. And then this line and this line we will delete. And go to create. Control point. Click, 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 and click. Very nice. So horizontal, horizontal, vertical, vertical. And now we could say U and U be equal. And now I move this 1 point. Oh, this one rotates because it is not vertically constrained. Vertically and horizontal. Thank you. Very good. This also horizontal. Ah, no, they are black. Very good. You see how I'm creating actually a nice curved part. And because I made those equal, I can just move 1 point and the other one moves because they're all vertical, horizontal constrained. I can just move my mouse left and right, up and down, and I'm not distorting the sketch. And with this CV curve, you can see now here, this is a really long line. So I'm stretching the curve, and then here I get 3 points together, and I'm pinching the curve, and then it goes back down. Pretty nice, no? Obviously, this is getting very tight. We could later round this a little bit to make this, to build up material. For what we do here right now, this is fine. Good. So there's our cap. We want to maybe hide this and then profile and axis. Very good. Let's take a look. Yeah, this is fine. And I would like to have some details there. So I want to draw something on top. I need to have a sketch on top. So offset plane. From here, go up by maybe 230, let's say 240. Okay. New sketch on this top view, zoom in, and I will go to somewhere else so it's out of our way. Here's actually, I can see where the edge of the cap is. Maybe I go with 1.5. I pressed D for the dimension tool, 1.5, and then vertically constraint, and D, I could also then specify what's the distance, 16.5. That's the radius of the cap of the outside. Okay, so because actually I made this ring, I can now go to extrude and extrude this one down. And you see when it cuts through, it does a cut. Pretty nice, no? Yeah. Okay. Then fillet. U. Chord is fine. 1 millimeter. Yeah, it's maybe actually a lot. 0.5. Okay. Again, with the chord, we get here a really nice consistent thickness because you see here the surface arcs. So technically speaking, this would get thinner. But visually, just this looks better this way. And now to create the pattern, create pattern circular features, U and U, along the Z-axis. And 30. Yeah, 30 looks good. Okay. Side this. Yeah, that's actually nice. That creates a good grip on the cap. Nothing is more annoying than when your wife with Superwoman power grip screws the caps on so hard that I get frustrated when I have to give back all the bottles at the bottle return. I need to unscrew all the caps. Yeah, that's what you put up with when you get married. But I love her. Very good. Sweet. So I would say we have actually a really nice design that's shelled. We have some cool details here. We learned about how to use the spline and the CV curve with the curvature control to create really nice fluid shapes. And I think we are ready to make our next video. Maybe tomorrow. Bye-bye.